Hello again. In this lesson we're going to be applying the distributive property to expressions. If we want to create a model for 2 times 5, that's really just 2 blocks of 5. If you think back to addition, 5 and 5 is 10, 2 times 5 is 10. Same will work with variables. So here we have 2 times b, that's b and another block of b. b plus b is 2b or 2 times b. So 2 times the quantity a plus b. Let's start with a plus b. That's a block of a and a block of b. Together they make up a plus b. So now if we want to double that, that means 2 a's and 2 b's, 2 ab's. So we start by making one AB block and then another AB block. So here we have the first and the second. Each are a group of AB. Well, let's go ahead and think about this. We have 2 A's and 2 B's in this block. So if we were to make a new diagram that has the A's and B's grouped together, it would look like this, AA, BB. So what is that? That's 2 A's here, 2 B's there, added together. So we can conclude that what we started off with, 2 AB's, is the same as 2A plus 2B. This is the heart of the distributive property. Let's look at some more examples before we generalize. So, doubling 3x plus 4y. Well, how do we write that out algebraically? 2 times, in parentheses, 3x plus 4y. Your model for that would look like a block of 3x, a block of 4y, and then another block of 3x and a block of 4y. Now, if we were to rewrite that with the x's grouped together, we'd have 3x, 3x, 4y, 4y, and from combining like terms, you know that these 3 x's together make 6x, and the 2 y's together make 8y. So, how can we generalize this? You can see that the 2 is really being multiplied by these coefficients inside the group there. That's important. We need to know that because in the next model, we won't be able to do it so easily because we've got a y that's really being distributed. Alright, so here up top we have the length, over here we have the width. Area of a rectangle is length times width. So, what can we do to make a model expression for that? 4x plus 5 is the one dimension, multiplied by y is the other dimension. Remember, that's the same as y times 4x plus 5. Commutative property says we can multiply in any order. So, to expand that, we're going to take and what we call distribute. Multiply this y times the things inside. So, it can work from either direction, it's just the same. So y times 4x is 4 times x times y. That's what 4xy means. And y times 5 is simply 5y. That's called expanded form versus factored form where we had 2 things multiplied, aka factors. So factored, now expanded form. So let's apply this in some practice. 3 times x is 3x, 3 times y is 3y. And we don't want to forget the addition sign in the middle. 4 times 2h, multiply the coefficients 8h. Multiply the 4 times the g, we get 4g. Bring the addition sign, don't forget that. 8 times h, 8h. 8 times 3, 24. Make sure you keep the addition sign. 44h plus 12g. Now another area model. Let's write it out in factored form first. J times 7k plus 12. That's the one dimension multiplied by the other. J times 7k, well that's 1j times 7, so 1 times 7 is 7, and then jk. And then 1j times 12m is 12mj. Well, to be in perfectly standard form, we'd rather write this as 12jk plus 12jm, keeping those in alphabetical order. Alright, one more example. A times 9b is 9ab, putting those in alphabetical order, and then a times 13, 13a, always putting the coefficient first.